Assalamualaikum dan salam sejahtera. Today we are going to present about engineering mathematics, trigonometry. I'm from group 1. My group members is Sriwansa, it's me, Silzia Rebecca, and Mathematic. I will pass to Mathematic to present about introduction of trigonometry.
Introduction of Trigonometry. Trigonometry, the branch of mathematics concerned with specific function of angle and their application to calculation. There are 6 functions of angle commonly used in trigonometry. These names and abbreviation are sine, cosine, tangent, cotangent, secant, and cosecant. The 6 trigonometry functions in relation to a right triangle are displayed in the figure. For example, the triangle contains an angle A, and the ratio of the side opposite to A and the side opposite to the right angle, the hypotenuse, is called the sine of A or sin A. The other trigonometry functions are defined similarly. These are functions are properties of the angle independent of the size of the triangle, and calculate values were tabulated for many angles before computers made trigonometry tables obsolete. Trigonometry functions are used in obtaining unknown angles and distance from unknown or measured angles in geometric figures. Trigonometry developed from a need to compute angle and distance in such fields as astronomy, map making, surveying, and artillery range finding. Problem involving angles and distance in one plane are converted in plane trigonometry. Application to similar problem in more than one plane of three-dimensional space are considered in spherical trigonometry. Basic trigonometric function formulas. There are basically 6 criteria used for finding the element in trigonometry. They are called trigonometric function. The 6 trigonometric functions are sine, cosine, secant, cosecant, tangent, and cotangent. By using a right angle triangle as a reference, the trigonometric function and identities are derived. First, sin theta equal to opposite side over hypotenuse, cosecant equal to adjacent side over hypotenuse, tan theta equal to opposite side over adjacent side, secant theta equal to hypotenuse over adjacent side, cosecant theta equal to hypotenuse over opposite side, and last cotangent theta equal to adjacent side over opposite side.
Thank you, Harit. Hi, madam. My name is Lizia. So next I will explain how to apply trigonometry in life. In everyday life, we often see a person measuring the road to be repaired or a multi-story building that is being built. The architects work using trigonometric comparisons. Trigonometric find its perfect use in modern architecture. Beautiful curve on the surface of steel, rock, wood, and etc. can be realized due to the great potential of designs. Computer imaging technology can be used tremendously in the world of medicine to find the source of some malignant disease. That is just a small part of the benefits of trigonometry. We need another reason to find trigonometry formulas to help our life. Here are some examples of the use of trigonometry in everyday life. For example, in navigation, to find the distance from the beach to a point in the sea. Trigonometry is also generally used in finding the height of towers and mountains. Trigonometry is also used in oceanography in calculating the height of seawater wave. Use it to measure the height of a tree. Trigonometry is used in finding the distance between celestial objects. Sine and cosine functions are the basis for the theory of periodic functions such as sound and light wave. Architects use trigonometry to calculate structural loads, roof slope, ground surface, and many other aspects, including sun shadow and light angle. More explanation about trigonometry in life. One of the most common architectural uses for trigonometry is to determine the height of a structure. For example, architects can use the tangent function to calculate the height of a building if they know their distance from the structure and the angle between their eyes and the top of the building. clinicometer can help you measure these angles. This is an older device, but the newer one uses digital technology to give more accurate readings. You can also calculate this distance of the structure if you know the clinicometer angle and the height of a structure. Next, thrust analysis and trigonometry. Designing a structure that can handle the load forces imposed on it is important for architects. They often use frames in their design to transfer the load strength of a structure to some form of support. Thrusts like beams but lighter and more efficient. You can use trigonometry and vectors to calculate the forces acting on a truss. An architect may need to determine the pressure at all points of the truss with diagonal members at certain angles and loads known to be attached to different spots. Last but not least, modern architects and technologies scrutinize the modern city skyline, and you will probably see a variety of aesthetic and sometimes unusual buildings. In addition to trigonometry, architects use calculus, geometry, and other mathematical forms to design their creation. Structure should not only be good but also must meet building's rules. Armed with high-speed computers and sophisticated computers shape design tools. Modern architects take full advantage of mathematical power. Unlike the magician of ancient architecture, modern architects can model virtual projects and modify them as needed to create interesting structure which attracts attention. Thank you.
We go to example question. Example question 1. Calculate the height of a building AB using trigonometry with a given measure. The solution for this question, we already draw the triangle with the measure given. Same as like at the diagram. We use formula tangent because we have the angle and the adjacent, and we are going to find AB or opposite. Tangent 16 degrees equal to AB over 15. AB is opposite, 15 is adjacent, and 16 is the theta. So AB equal to 15 tan 16 degrees, and the answer 86.60 meter. Next question, calculate the distance from point A to point C using trigonometry. We use same diagram here, but different question. The solutions for this question, we already draw the triangle, and we are going to looking for AC or the hypotenuse. We use formula cos because the formula cos is adjacent of hypotenuse, that we have the adjacent and the angle, but we are going to find the hypotenuse. So cos 16 degrees equals to 15 over AC. 15 the adjacent and the AC is the hypotenuse. So AC equals to 15 over cos 16 degrees, and the answer is 100 meter. Last question, we are going to find the angle theta. Can we look at the diagram? We have the height of building and the distance from A to the building. Solution for this question, we already draw the triangle ABC, that the B to C is 200 feet and A to C is 115 feet, and we are going to find the angle theta. How can we find the angle theta? We use formula tan or tangent. That formula are opposite over adjacent. We have the opposite is 200 feet and the adjacent is 115 feet. So tan theta equals to 200 over 115, and theta equal tan inverse 200 over 115, and the answer that we get is 51.13 degrees. Next is, as a conclusion, we realize that trigonometry can be used in many areas such as trigonometry and architecture that can aid in calculating many things. They can also be used in cars, desks, and bench. Without really climbing a tree, you can find the height easily with trigonometry. They can be so widely used in real-life application and is very useful for most architects and astronomers. That's all from us. Thank you.